Business Mathematics for CA and Corporation. We are focusing on Module 3, that is Basic Algebra. In this, we are focusing on interpolation and extrapolation. So, interpolation and extrapolation are statistical method. So, it is a statistical method for estimation and for forecasting. Statistical method for estimating a particular value or forecasting a particular value. Now, let's see what is interpolation and extrapolation. For example, consider a sequence 2, 4, 6. Then you're asked to find the value which is between these two known values, that is 6 and 10. You're asked to find the value. What is the value which lies between 6 and 10? Okay. So let's find in which sequence it goes. So this series goes up in the form of skip count of 2's. Skip count 2's. So 2 plus 2 4, 4 plus 2 6. So obviously 6 plus 2 will be 8. So the value which lies between 6 and 10 is 8. So this is called interpolation. This form of sequencing, this form of estimating the particular value within two known values of a sequence of value is called interpolation. So interpolation means it is an estimation of value which is carried out within two known values of a sequence of values. Then, now let's see what is extrapolation. Extrapolation means if I am going to extend my series. So let's consider the series 1, 3, 5, 7. Then what will be the next number in order to fill? So this is extending my sequence of value within a known area. So it is clearly an odd number. So 1, 3, 5, 7. So obviously the next number will be 9. So extending a particular series of values with respect to a known area is called extrapolation. So interpolation means in between the two known values called interpolation, and extrapolation means estimating a particular value by extending an available sequence of value beyond a known area is called extrapolation. This is what extrapolation. Now, what are the methods used for finding interpolation? So, for method of interpolation means there are two methods for interpolation. One is graphical method and another is algebraic method. Okay, in a graphical method you need to take care of these two things. So, in graphical method we arrive at a solution by plotting the particular graph. Plotting the particular graph using the particular data given. So we need to draw the particular graph and the independent variable x is taken along the horizontal. So independent variable is always taken along the horizontal axis and dependent variable will be taken as a vertical axis. So independent variable will be always taken as a horizontal axis and dependent variable will be taken as a vertical axis. These are the two main things that you have to keep in mind. Then you are asked to the points so plotted are joined by a line or a smooth curve. Depending upon the value, it is plotted and joined by a line or a particular smooth curve. So the value of independent The value of independent value is marked on horizontal axis and a line perpendicular to x-axis drawn to intersect the value to arrive at the value of f of x. So this is how you have to tackle the graphical method. In graphical method, for plotting the particular graph, independent variable is taken around the horizontal axis and dependent variable along the vertical axis. And while plotting the particular points, when you are joining the particular points, it can be either by a line or a smooth curve. Okay, so let's see one example using a graphical method. So using the graphical method, you are asked to find what is the corresponding x and y. So you are asked to find the value of y when the particular x is equal to 38. So the x values are 10, 20, 30, 40, 50, 60, and y values are 63, 55, 44, 34, 29, 22. So the first step for solving a particular graphical method is you need to take a suitable scale. Suitable scale for values of x and y. Then once you got the suitable scale for x and y, you can start plotting the particular points on the graph paper. So here on our x-axis, each unit is 10. So 10, 20, 30, 40, 50, 60, 70, 80 in x-axis, as well as in y-axis I have used the same unit 10, 20, 30, 40, 50, 60, 70. Now we are going to plot the particular points. So on x-axis your value is 10. So corresponding y value is 63. So it is pointed out over here. So this is your point, first point. So this is your first point. So 10, 63 is marked over in this point. Another one, when x is equal to 20, the corresponding y value is 55. So this is your next point. Now we are asked to find when x is equal to 30, corresponding y value is given as 44. So 4, then 4. So this is 44. Then in 40, when x is equal to 40, the corresponding y value is 34. This is your value 34. Then when x is equal to 50, the corresponding value is 29. And x is equal to 60, the corresponding value is 22. So you have plotted all the points. Now if the corresponding points, the plotted points are forming a line or a curve. Since it is a curve, literally slight curve over here. So we have draw a suitable curve passing through the plotted points. Now what happens is you need to find the value of x when x is 38. So your question was, if the value is 38, if the value is 38, you need to find what is the corresponding y value. So we have drawn, you can see the green line which is moving up till the dotted line. So this is your 38. X is equal to 38, and the corresponding y value is joined perpendicular to this particular line, intersecting the y value, and this is 35. So when x is equal to 38, the corresponding y value is 35. Corresponding y value is 35. So in order to the value of independent values marked on the horizontal axis, that is 38, and the line perpendicular to x axis drawn to intersect the line to arrive at the value of f of x. And this is how we have come to a conclusion that when x is equal to 38, the corresponding y value is 35. So in order to solve the graphical method, first step is you need to use a suitable scale. So once you got a suitable scale for the value of x and y, you can plot the particular points in the graph paper. Then after plotting the points, draw a suitable curve passing through the plotted points. And after that, you need to find the point which is corresponding to the x is equal to 38 on the curve and the corresponding y value on the y-axis. And hence we have concluded that this is an interpolated value because it lies between 30 and 40. It is 38. So it is an interpolation This is how you need to tackle graphical methods for solving interpolation. Now let's see some of the examples from your text. So here you are given a table showing the population of a town. Interpolate the population for 1982. You are asked to find the population for the year 1982. So you have given the years 1980, 1990, 2000 and 2010. And the population in years is 6.2, 7.2, 9.1 and 12.0. So we started the points. We started from 1940, then 1960, 1980, 2000, 2020. So first one was in 1990, the point is 6.2. So this is 6.2, 1990, it is 6.2. This is the first point. And in 1990, it is 7.2. So this is the next point. And in 2000, it is 9.1. And the third one, 2010, it is somewhat 12. So this is how the curve. So we have plotted all the points, and we draw a suitable curve joining all the point. Now the next step is you have to find the population of the population in 1982. So 1982 is somewhere over this point. This is 1982. So we have dotted lines to reach up to this point, and with this point we draw a horizontal line to the y-axis, and we got the point over here. So this is in x, when x is 1982, the y value, corresponding y value will be somewhat 6.4 in your graph. Okay. Now, how do we solve the particular interpolation in the form of a graphical method? So for the graphical methods, in this question, the life expectancy E of particular male in year 2000 is 68 years, and if it is increased to 75 years in 2014, you need to express E as a linear function of T. Okay, so you are given that life expectancy of male in the year 2000 and the value is 68, and if it is increased to 75 years in 2040, you are asked to find the particular linear function of T. You need to express that linear function. So that the linear function is expressed in the form E is equal to, E is your life expectancy. So E is equal to AT plus B. This is the linear function for expressing the life expectancy. So life expectancy E is expressed in the form of a linear function, that is AT plus B. Now, we are considering our base year as 2000. So we are considering the base year as 2000. So base year is considered as 2000. So the value of A is denoted as 0. Value of T, that is time, year is considered. Okay, now what we are going to do is we are going to substitute this in this particular linear function. So we are considering the base year as 2000. So the expectant year in 2000 is 68. So 68 is equal to, we don't know the value of A. Then the time period, since it starts from 2000, we represent this number 2000 as 0. So T is given as 0 plus, we don't know the value of B, so write the B as such. So the B value is 68. Okay, now we need to find if it is increased to 75 years in 2014, what will be the corresponding year. So in the same expression for the with the same linear function, we are going to substitute the value, that is 75 is equal to A. Here the time is 2014. So the base year was 0 in 2000 and the base year is 2014 now. So the time is taken as 14 plus the B value is, we have to find the B value. So substitute the B value as 68. So if that is implies 14 A is equal to 75 minus 68. So 14 A is equal to 7. So A is equal to 1 by 2. So the value of A is 1 by 2. The value of B is 68. Now we have to find the life expectancy in the year 2020. So in year 2020, what you have to do is you need to substitute the value of A and B to that particular expression in this expression. So E value, we are asked to find the E value. So E is equal to, A is given as half and the time is 2020. So 20 plus B value is 68. So that is half of 20 is 10 plus 68 is 78. So the life expectancy in the year 2020 is 78 years. I repeat, if we are applying the algebraic method, you are asked to, in this question it was given the life expectancy of male in year 2000 and the value is 68 year. And if it is increased to 75 years in 2014, you have to express E as a linear function of t. So the linear function is expressed in the form E is equal to AT plus B, where t is the year. So according to details given, we consider the base year as 2000. Since it is 2000, we consider the time as 0. So, according to the first statement, the life expectancy of male in 2000 is 68. So, 68 is equal to A into 0 plus B because it is 2000. It considers 2000 as the base year. So, it is 0. So, from that equation, we got the value of B, that is 68. Then according to the second statement, if we increase the life to 75 years in 2014, in 2014 the expectancy year is increased to 75. So 75 is equal to A into T. Here the T is 14. In 2014 the T is changed to 14. So 14 plus what is the B value? 68, and we got the value of A as half. Now substituting the value of E, substituting the value of A, T and B for 2020, we got the life expectancy in 2020. That is half of 20 plus 68. That is 78 years. Now let's see one more example. So in this example, you are given the data in such a way that the following data are collected after survey of a soft drink manufacturing company. So the number of bottles is 20,000, 15,000, 10,000 and 5,000. So the price in rupees. So when the price is 1 rupee, the bottles collected is 20,000, and when it was increased to 1 rupee and 50 paise, it is 15,000, and increased to 2 it is 10,000, and 250 it was 5,000. So you need to find the functional relationship. You need to find the functional relationship between the price and the number of bottle. Here, hence, we need to find the number of bottle, estimated price of 150. So estimated price of 150 will be between 150 and 2 pi. So the value will be over here. So it is a clear case of interpolation. Okay. So now what you have to do is, from this we can see that if a 50 paisa increase happen, there is a 5,000 reduction. The number of bottles are decreased. 5,000 bottles decreased if 50 paisa is increased. So when 50 paisa increased, the number of bottles is reduced to 5,000. If that is the case, what is the value if it is 150? If 150, the number of bottles is 15,000. Then if it is 2 means, 2 rupee means the number of bottles is reduced to 10,000. So clearly this will be between 150 and 2. The number is 170. Okay, you need to find the difference. So it is, so the difference is 5,000 0.5. So if 0.5 price increased, the decreased amount of bottles is 5,000. Now let's see if it is increased to 0.2, then what will be the value? It is 2,000. 2,000 decreased. So from 15,000 you need to subtract 2,000. So that is 13,000. So if it is 1 rupee and 70 paise, the number of bottles will be 13,000. Okay. So in this question, the data collected after survey of a soft drink manufacturing company, the number of bottles is 20,000 when the price was 150, it was reduced to 15,000. When it was 2, it was reduced to 10,000, and 2 rupees 50 paise, it was 5,000. So you are asked to find the functional relationship between the price and the number of bottles. So how do we estimate the price if it is 150? So if it is, there was a 50 paise increase, then there is a decrease in 5,000 bottles. So 5,000 by 50 paise into 0.2 give you an answer 2,000. So 2,000, from 2,000 you have to subtract the value of 15. So you got the 13,000. So in 4 and rupees 70 paise, the number of bottles is 13,000. Hope this is clear for you. In the next session we will be dealing with quadratic equation.